It's a good morning. It's a good morning to you all, guys. I'm continuing with the paper. Remember, a day ago, I was doing the short questions. A day ago, I was doing the short questions. So I'm doing the long questions now, which is the one that is a total of 15. That is what I'm doing today. The ones that I've got a total of 15. This one is a booklet that is made up of different activities, but it covers mostly geomorphology. Geomorphology. I'm going to start off with the concept of river capture. Start the diagram below. On river capture. This is the diagram that we have. We have got the before diagram and after river capture. Okay, the before diagram and after river capture. So in as far as river capture is concerned, you should be able to identify what the diagram looked like before the process of river capture and what it looked like after the process of river capture, because this will help you to have an understanding of how the process take place. This will help you to have an understanding of how the process take place. So this is very important. Because most cases you are given, it can be a sketch, you are given, it can be a diagram, and here you are applying the concept of river capture. You are applying the knowledge. It's not a matter of reciting, but you have to apply the knowledge that you would have learned about a certain concept. So this is very important for you to know the before river capture diagram and also the after, and if possible your ability as well to label all the parts in the after river capture is also very important, because you can be assessed. They can ask you which one is the misfit river, which one is the captured stream, which one is the captor stream, and also which one is the elbow of capture and which one is the wind cap. So you should be in a position to know the process in detail, how it takes place from before the river capture and after the river capture. So what we have here, we have got river C, you can see. Then we have got what? River A, as you can see. This is river A. So if you look at the two rivers before, you can see what is happening, okay? This one, there is headward erosion, which is backward, which means it's cutting back to its source. It's cutting back to its source, cutting through the watershed, which is what separates the two rivers. The watershed is what separates the two rivers, okay? What does the energy of river C come from? The river flow over steeper slope, that's number one. Volume of water increase throughout prolonged rainfall. River flow over less resistant rock. Therefore, it erodes faster. It flows at a lower angle. There are cracks and joints in the rocks that makes it easier to erode. So that's basically what we are looking at. And the type of erosion that is taking place is headward erosion, which is backward. Remember, headward erosion, what it does, it increases the length of the river, but it can be forward or backward. But here is backward because it's cutting back to its source, cutting through the watershed. And as you can see now, that process has taken place, backward erosion, and it has captured the headwaters of A. So this is the more energetic river, it capturing the headwaters of a less energetic, which is A, through backward erosion. That's the process that has taken place now. As a result, you can see there's more increase in terms of rainfall flowing in river C. That's basically what we are talking about. There's more rainfall in terms of water flowing in river C, which is the Captor River, CAPTOR, Captor River, and this one has been captured, which means the one that is left with a misfit at B, that is river A, it has been captured. So that's basically the process that is taking place, which means here you can see that is your wind gap at E, at D, that is your elbow of capture. So you should be able to label the different parts after the process of river capture. You should be able to know also what happened when the process of what happens when the process of a river capturing is taking place. So let's move on. So the first question reads, define river capture. When you are defining, you are giving the definition. What is river capture? So what you need to acknowledge, it is a process where A more energetic river captures the headwaters of a less energetic river. This is what is happening. This is your more energetic river. This is a process whereby a more energetic river captures the headwaters of a less energetic river. It is also known as stream piracy. It is also known as stream piracy. So you can say river capture takes place when a strongly eroding river steals the water of the less energetic river. I don't prefer the word steals. I prefer the word captures. Okay, I prefer the word captures. So this is when a more energetic river captures the headwaters of a less energetic river. Less energetic river. Okay, even though some might prefer steals, but I prefer captures. I prefer captures. It sounds more geographical. Okay, this is when the headwaters of a more energetic river, which is our sea, captures the headwaters of a less energetic river. Okay, then the next question, what type of erosion is dominant at river capture? Remember, we said that there is more headward erosion, which is backward. It's cutting back to its source. That's how it cuts through the watershed to capture the headwaters of a less energetic river, which is river A. So the answer there is a headward erosion. The answer there is what? A headward erosion. The answer is headward erosion. That's what is happening. Name the places labeled A, B, D, and E. What do we have is our B. A B, this B is a misfit. This B is a what? Misfit. Okay. Our D is the elbow of capture. Elbow of capture. Then our E is a wind gap. This is a wind gap. So you should be able to label, you should be able to label. That's very important. So here we have said it's headward. Okay. Erosion. So the diagram we have labeled here, okay? Then state 3 conditions that will increase the possibility of a river capture. Okay, what increase the possibility of a river capture? That is your 2.4.4. What increases the possibility of a river capture? Remember when I was explaining, I said that this is on a steeper slope, that is your river C. So the river flows over steeper slope, okay? One river is a steeper gradient than the other. So we are saying now one river is a steeper gradient than the other. That's number one. Okay, there's a steeper gradient than the other. What else can we talk about? The other one is supposed to have a large amount of precipitation. One river, okay. One river is a larger amount of water, of precipitation. Let me say precipitation, which means precipitation than the other. Of course, precipitation we're looking at, referring to as the amount of rainfall that falls, okay, into this river. So it's supposed to receive more precipitation. That's another condition actually that results in the formation of our river capture. And the other one has to flow over a less resistance. Okay, one river also flow over less resistant rock, okay, which helps it to erode very fast. One river is flowing at a lower altitude than the other, okay, and so on and so on. So these are the 3 conditions that actually increase the possibility of a river capture. One river is a steeper gradient than the other, one river is a large amount of precipitation than the other, and one river flow over less resistant. That's basically what we are talking about. This is what the conditions that is conducive for a possibility of a river capture. So one river has a steeper gradient than the other. One river has a large amount of precipitation than the other in terms of it having more water. Okay, that's what makes it also to erode fast, so that there's headward erosion, so that there's that backward erosion, so that it's cutting back to its source. Okay, so which means the more water that it has, it actually gives us more energy to erode. That's basically what we are talking about, which is cutting back to its source. It's because of the velocity of the water, of the water that is within that river. Okay, one river flow over less resistant rock. So these are the conditions that will increase the possibility of a river capture. Explain how the characteristics of the riverbed. Explain how the characteristics of the riverbed level C will change after river capture. So we are now saying now, they explain how the character of a river labeled C. This is a river labeled C, which is our more energetic river that has captured the headwaters of a less energetic, which is A. So what will change to this more energetic river? That's basically what we are talking about. So number one, it will become more erosive power because of the amount and the turbulence of the water added, because now there is more water in C. So this is what makes it to be erosive. And also the turbulence of the water will also be added, because now it has got more power. The water is flowing at a higher speed. That's basically at a faster speed. That is higher velocity. That's basically what we're talking about. So the river erosive power will increase because of the amount and turbulence of water added. The volume of water will increase because the headwaters of the capture stream is added as well. So we're saying that there's going to be more water because it has captured A. There's going to be more water in C. Then also the velocity of water will increase because of more water. That's what will happen. The velocity of water will increase because there will be more water. Please make sure when you're answering this type of question, it's more like a paragraph question. Of course, they did not highlight paragraph question, but there's a question here, this part which says explain, which means you need to give a detailed explanation. You have to give a detailed explanation. Don't be vague. That's basically what this is all about. So if you answer like erosive power increase, you get 1 mark. If you say erosive power increase, you get 1 mark. But if you answer it in full like erosive power increase because of the amount and turbulence of water added, which means that point is explained. There is a point, factor, and the qualifier. Erosive power increase because of the amount and turbulence of water that is added. That point is got that answer is got a factor and the qualifier. It's explained in full. If you just say volume will increase, you get 1 mark. But if you said volume of water will increase because of the headwaters of the capture stream is added, okay, then you get your 2 marks. If you just say velocity will increase, you get 1 mark. But if you say velocity of water will increase because of more water, you need to give more information so that you get all the marks. So let's move on to another question that also covers river capture, so that we exhaust the concept. Okay, refer to the sketch below on river capture. So this is river capture. You remember I've given some light on how this process takes place. So you've got 2 rivers here, before capture, this is after capture. So what should help you guys is you can see after capture, you can see now this one, because of cutting back to its source, cutting back through the watershed, is going to capture E. That's basically what is happening. This is what has happened here. You can see now the E has been captured because of headward erosion that is backward through this stream C. That's basically what is happening. This is before and after. So please make sure that you know what happens before and what happens after as well. You should be able to identify, is this the after or is this the before diagram? So, or is this the after or before sketch? So this is very important when it comes to river capture. So let's go through it, because I have already shed some light on what river capture is. Define the term river capture. This is when a more energetic river captures the headwaters of a less energetic river. This is a concept, please. You have to get it right. Indicate that this is a process whereby a more energetic river captures the headwaters of a less energetic river. This is a process. It's very important that you write or you answer this correctly. Okay. What is the process responsible for the lowering of watershed C? So that is your headward erosion or abstraction. You can put it that way. That is your headward erosion here. That is your what? Headward erosion. That is your headward erosion. Or I can say abstraction. Okay. Headward erosion or abstraction. You got your answer. What evidence of the river capture? What evidence of river capture will one find at A? What evidence of river capture will one find at A? So this is where your A is. So what evidence of river capture will one find at A? That they've even indicated that it's the elbow of capture, and B, wind cap. What evidence will one find at A? Okay, it is the point of capture where the pirate stream joins the captured stream. Okay, that's basically what we are talking about. It is the point, okay, here we are referring to this elbow of capture. It is the point of capture where the pirate stream joins the captured stream. So that's basically what it's all about. That's what this is all about. That's the evidence that is there. Then also a B, wind cap. The river wind cap, okay, the river gravels that show that a stream once flowed before river capture. So those are the evidence that shows, because obviously it used to flow, but now that it's no longer flowing. So we are saying now river gravels that show that a stream once flowed before river capture. So those are the evidence. Those are the evidence. This is where the capturing has taken place. That's basically what we are saying at the elbow of capture. This is where the more energetic river has captured the headwaters of an less energetic river. This is the point at which the capturing has taken place. So those are the evidence that you can actually use. So it's a matter of you knowing these features on a river capture, because you cannot explain or you cannot answer a question about what has happened if you do not know what these points are and what happens at these different points, that is at your elbow of capture and also at your wind cap. Thank you. Let's move on. What caused the stream at sea? What caused the stream at sea to capture the headwaters of stream E? What caused river capture? That's basically what they are asking. What are the causes of river capture? They ask indirectly. Some of these questions are not straight. Some of these questions are not direct. So they ask indirectly. What causes river capture? This is basically what they are saying. What causes river capture? That's what they are saying. 2.4. What caused the stream C? This is the stream C to capture the headwaters of stream E. Okay, that is 2.4.4. So remember, I once talked about steeper gradient on the side of stream of C of the watershed. Remember from the previous question we talked about this. Okay, steeper gradient on the side of stream C, steeper gradient on the side of stream C of the watershed, which means it's cutting back to its source. Okay, the steeper gradient there on the side of stream C of the watershed. Stream C is low-lying stream with more energy. This one is low-lying stream with more energy. Of course, it's cutting back to its source. Okay, it's a low-lying stream with more energy. Then also the higher precipitation giving greater runoff and more erosion to C, which means the more precipitation, okay, that is received by the river C, which gives it actually more energy. Okay, then softer rocks on the side of the stream C cause faster erosion. The softer rock also that cause faster erosion, so that the process of river capturing takes place. The presence of faults and joints and rocks to assist erosion process. So those are some of the things that you can actually write, but you only need one from what I've said. Then in a paragraph of approximately 8 lines, explain the physical changes on river D. Okay, the physical changes on river D will experience as a result of river capture. So river D, what is happening now? River D, because of this stream is a tributary that is adding more water into the river D. Of course, it has cut back to its source through headward erosion abstraction to capture the headwaters of E. Okay, so what will happen now to D? So D is this stream. This is the D stream. This is a tributary. This is a tributary. This also, C, is a tributary to D, but is cutting back to its source through headward erosion abstraction to capture the headwaters of E. So in a paragraph of approximately 8 lines, explain the physical changes in river D will increase as a result of river capture. 2.4.5, number 1, talk in relation of the volume of water. The volume of water increases in the stream. The volume of water increases in the stream. So which means downward erosion increases. So as the volume of water increases, it means downward erosion also increases, which means there's more of vertical erosion when the volume of water increases. That is in D now, because we're talking about what will happen in D. Because we are saying now the moment this river D receives more water, it's rejuvenated. That's basically what we are talking about. It becomes rejuvenated. That is why it's resulting in downward erosion. But the volume of water increases in the stream, which results in downward erosion. Okay, then also the volume of water increases in the stream, which results in the carrying capacity of the river to increase, which means it has got energy. It can now carry more soluble and insoluble substances within the channel, within the river. Okay, that's basically what we are saying. And also the river rejuvenates, which means it has been given more energy. It results in river rejuvenation. That's basically, the river is more erosive. There's all downward erosion taking place. Okay. The valley of the river will also widen. There's more of lateral erosion that will take place on D. Then also the flooding may also occur. So these are the physical changes that the river D will experience. I'll say it again. As a result of the volume of water increasing in the stream, there's more downward erosion. It will increase. The carrying capacity of the river will also increase. The river will rejuvenate, which means there's more of downward erosion that will take place. The river has got more energy. Then the valley of the river will also widen, which means there's going to be more lateral erosion within that river then, okay? Then the valley, the flooding may also occur, something that will also happen in as far as river D is concerned. Okay, the nick point or sharp break in the slope created near the point of capture due to rejuvenation. So there's going to be a nick point, a sharp break in slope created near the point of capture here, near the point of capture where you've got the elbow gauge. There's likely to be a nick point which will also cause the river rejuvenation. So that's what will happen there. That is your 2.5. So this takes us to the end of river capture. Thank you.